and welcome to the 6-5 Summit. I'm Shelley Kramer, one of the founding partners here at Futurum Research, and on behalf of my team at Futurum and the team at Moor Insights and Strategy, welcome. We're glad to have you. In this spotlight session, Moor Insights' Patrick Moorhead is joined by Tony Uttley, the President and Chief Operating Officer of Quantinuum. In this conversation, they discuss the progress of quantum computers and what the future will hold for this fascinating industry. This is a timely conversation and one I'm pretty sure you won't want to miss. Let's get to it.
Tony, welcome to the 6-5 Summit. Thank you so much for coming on.
Thank you for having me. It's great to be here.
Yeah, it's great to see you again. I mean, you've had a very exciting couple years. We've gotten to know each other and the team really well. I mean, whether it's Honeywell, whether it's you coming together with Cambridge, now as Quantinuum, the action never seems to stop.
I think that's right, and I think that's one of the most exciting things about the quantum computing space is, I know a lot of people describe it as this technology that's always 20 years away, but this is the decade. This is when it's happening, and the advancement has been and continues to be terrific.
Yeah, it's great. I'm going to hit you with the first question I have for you is literally the first question I get from everybody who's not inside of the quantum computing industry. And that's how long before quantum computers are commercially useful? Not necessarily better than anything else, but just commercially useful.
Yeah, I get that also all the time. And I don't know if it's funny is the right word. December of 2021, so that'd be last December, that was a big moment that happened, and that was when quantum computers became commercially useful. It happened. It already happened. So why? Why is that? Because we're in an era where people are talking about still being able to not just classically simulate what is going on with the quantum computer, but being able to do that on your laptop. Is that a true statement? Yes, that is a true statement. So how can quantum computers do something today that are useful? Because it turns out that they are quantum mechanical systems. And so when we have things, and people will have heard these terms, but they're so special to quantum physics and quantum mechanics, things like superposition, which is the ability for these wonderful qubits to be in both a 0 state and a 1 state simultaneously. Things like entanglement, where you have something that you can know about these qubits if you have imparted quantum information in them together and then separated them. When that's happening in a quantum computer, it is really happening. When it's being simulated in a classical computer, those things are not happening. So what happened when you took a quantum computer and you actually created these superpositions and you actually entangled them? Well, we are now able to generate the most secure encryption keys that have ever been generated. Why? Because encryption keys need to be unpredictable, completely unpredictable. They need to be random. And the thing that quantum computers can do, if you know how to do it well, is to be able to use the quantum mechanics to create these perfectly random output that you know what it is, you can verify it, and it is something that's called non-deterministic. Non-deterministic meaning there isn't a way, there isn't another method to be able to figure out what that random number really is. That has already happened and now is available. It really became the first product that can use a today quantum computer.
Yeah, so interesting, Tony. So you actually took something that some people might feel is a challenge with quantum computers and turn that into a positive. So just for the viewers, Tony, can you tell everybody what is the name of this service and how can they get it?
So yeah, we very appropriately called it Quantum Origin, and I love that. I continue to love it. Quantum Origin is both the service of providing these encryption keys, so quantum computing enhanced encryption keys, as well as the protocol that can be used to be injected into a company's current method for creating these these encryption keys, but being able to do so with a quantum enhanced way. So we do that today, and there are already customers that have taken Quantum Origin and put it into production. Pure VPN is one of them, where their customers are now having access to their VPN service that has been protected with quantum computing enhanced encryption keys.
So, they say never to ask a follow-up question unless you know the answer. And I think I know the answer to this next one, but I do think it's important for people to understand this in context that, hey, we're happy that we have something that's commercially useful, but, is the team satisfied? Satisfied where they are, I know, but are you satisfied with the progress of quantum computing?
Yeah, that's a great question. I guess as the president of any organization, you can never be satisfied.
Exactly.
But I am thrilled with the progress of quantum computing, and it's hard, I think, for most people to live in the moment and then try to step back and think about some of these things historically. Like, what has happened? What has happened just in the last few years? And what has happened is that quantum computers exist. Yeah, it was a big deal, a profound moment in time where quantum computers exist and you can use them to do these quantum computations. And then a lot of people's heads got wrapped around, yeah, but you can simulate it classically. No, that's a great period of time. Again, something that will only exist in a sliver when we look back on this in the future, is that you could do quantum computations on a quantum computer and then check the results with a classical computer to start to build up that confidence and trust that you get the correct answer. In the meantime, we find out that we can do something profound with the systems that exist today, like Quantum Origin. We can use it to create these near perfect encryption keys. So is there a lot to do? Yeah, it's called the future. There's a huge amount to do. Every decade is going to be great. But are we making the progress that we said we were going to make? Yes. And I think that's the other one that was really big for Quantinuum is, I personally made a statement in March of 2020 saying we were going to release our first quantum computer in June. We said what the quantum volume, which was this measure of its performance, what it was going to be, and that every year for the next 5 years, we'd be able to increase that performance by an order of magnitude. And we have done that absolutely, as we said we would, make the data available and showcase that these systems are incredible, especially if you know how to precisely control them.
So Tony, I want to move to ecosystem here. So, every new technology has its ecosystem of investors, startups, pundits, the press. Now we've got the social media. Requires some excitement to get an investment cycle, right? Sometimes some people might call excitement hype, and some people I've heard say, "Hey, there's too much hype in quantum computing on that." And what are your thoughts on that? Is there too much hype in quantum computing right now?
I think there's a lot of risk to too much hype in quantum computing. But it starts in a very interesting place. I had the absolutely enormous pleasure of being able to participate in the Hudson Forum that was put on by IBM, in fact, just in early May. And something was said during one of the panel discussions that was so profound to me, which is the sense of wonder that is inspired by quantum computing is so high. And it's kind of knowledge that quantum computing is this incredible thing and can be the future is so widely known, yet nobody knows anything about it or how it works. But the sense of wonder is incredible, and this future potential just exists, which is what a great place to be. What a great technology where everybody's like, wow, this is going to be great. And then there's this gigantic gap between people who would say that and know where we are today. And so there's such a important part of making sure that every step of the way is very factual, supported by data, has third parties, especially credible, academia, national labs that can take the opportunity to do these sanity checks and say, where are we really? And then it's incumbent upon everybody who's participating in the ecosystems, companies like Quantinuum, where we have to embrace the sense of wonder, but at the same time say, here's where we are, everybody. Here's what the technology actually does. Here's the progress that we're making. And by the way, that's incredible too. It's an exponential progress, but we just have to remind ourselves that we have to support that with evidence.
I love the phraseology sense of wonder. And it, I was young when we started to go to space, but older enough a few years later to see how space really struck that tone. And it's very similar to that today. And I think that hype is an important thing, if nothing else, to paint the vision. In quantum, because we have so many academics involved, there's so much less hype than I've seen in other industries. Let's say like, full self-driving cars as an example. So, but I think it's important. But I love the idea of it being a sense of wonder, because that gets people interested in it. So,
yeah,
many of these applications are still years away, but we don't have companies just kind of sitting around and waiting for that. So, what are companies today doing in that field between now and when some of these applications come out?
Yeah, that's excellent. Maybe okay. I'm going to give an assignment to the audience, which is just pick a company and Google it and say, is that company working on quantum? Is that company working on quantum? And you're going to find that there are a lot of really big companies around the world, organizations around the world that have dedicated resource to quantum computing. Why? Why would they do that? Especially when you're at a time where in the sense of quantum computation, you can simulate that classically and oftentimes just on your laptop. And it has to do with what I said earlier about this period of time that we're living in, where that by itself is incredibly valuable.
Yeah.
That we can compute a problem, and to call them toy problems is a disservice to the entire industry. We're taking problems and shrinking them down to solve on the size of quantum computers that we have today. And the performance of these computers is increasing fast enough that you can keep on adding harder and harder problems. And then you can check to make sure that it's getting the right answer. All that is happening right now in a advance of when we cross that threshold where you can no longer check the answer on a classical computer. Even the most powerful supercomputer on the planet, you wouldn't be able to check that answer. And so companies are spending the time because the potential is so profound that they want to be quantum knowledgeable. They want to have, if you could even call it, they want to have quantum native people, so that they're thinking about these problems in a way that you can then translate to be solved on a quantum computer so that they are ready. Because the organizations out there realize that even if you come up with something great, to be able to build that into your typical business process, that's 3 to 5 years to be able to do that. And so putting the resources in now to figure out how you'd make those process changes, where it would come into play, what parts of your organization would have to change, is what's happening. And it's the right thing to do. It really is the right thing to do, to be prepared, to be able to maximize when this can take advantage for your company first.
Yeah, Tony, that makes perfect sense. And it reminds me of how machine learning got popularized with ImageNet, where one of the first big tricks that ImageNet would do is to be able to determine if it's a dog or a person. Okay. And then as you got better hardware, better algorithms, it's a brown dog with a collar sitting in a park. Brown dog, actually a golden retriever sitting in a park in New York City because you could identify the buildings behind it. So, in a very similar way that I saw, at least, image intelligent image identification. This is the way it's happening today. And now here we are in machine learning, where we're doing a lot more than just determining if it was a dog or a person.
Right.
So I understand that you're launching a new quantum computational chemistry product. Tell us more about that. How did it come about? Why do customers need something like this?
Yeah, no, this is fun. So just last week, we would have announced to the world that we are releasing a product that's called Inquanto, and the idea behind it came from the work that we were doing with our customers. And this is, I love the story because this is how products should work. All products. We were doing projects with big pharmaceutical companies, material science companies, chemicals companies on these profound, big, meaty use cases. And to try to do that project, we developed software. And then we found out that that software was applicable across a lot of these different projects. And so we continued to build that software out. And then we had our customers saying, hey, I saw you guys using some software. What is it supposed to do? And can we get access to it? And so, yeah, sure. We shared that and let people use it. And then it was, wow, this could be a real thing. And so we built out a version of it. We did beta testing with customers, again, across material science and pharma and chemicals. And then you ask the questions that you should always ask.
Right.
Do you find this useful? And would you pay for it? And it turned out that the answer to both of those two questions was yes. So we said, okay, well, it is right. It's the right time to be able to launch this quantum computational chemistry product. And we then have to realize where we are in history, right? This allows computational chemists to think through the steps that they have to take to translate their problems into quantum problems. That's what's going to happen. That's how you make a quantum educated workforce and start to be a little bit more quantum native in how you think about these things. And then you can apply your problems to real quantum computers, so that as these quantum computers continue to increase their performance level, you can start to do harder and harder problem sets. And so that's where this came about. And is it, 1.0 of something that will have years of usefulness? Well, that's the intent, right? And it's working with these customers then who side by side with us tell us in all the nitty-gritty detail what things they hate, so what things would you change, which again, that's the way you want to develop a product. You want to get that feedback in real time, iterate on it, and make it so it is useful. Now, is it like 1,000 people at each of these companies kind of a thing right now? No, it's the handful of people who need to do the really challenging quantum computational chemistry type problems. Now, will that grow over time? Yes. And again, in a way of thinking about a future both business model, but also applicability, it's outstanding. But right now, get it in the hands of the experts, get it in the hands of people who are going to find the high utility in their own job, in their own processes, and then give them that extension to be able to run those on real quantum computers.
It's exciting to see a lot of these, formerly known as high performance computing areas get a big boost from quantum. When will people actually be able to use this? Is it available now in a couple months?
It's available now. So
that's wonderful. That's exciting. That's what you like to hear. Quantum and now. You heard it here first, right? Not only do we have the one of the first commercially useful applications out there with security keys, but now we have a computational chemistry product out there. Does it have a special name?
Yeah, it's Inquanto. And
so cool.
It's, as you hear things like in vivo and things that would be that, how do you take the next step of using quantum as you think about your chemistry problems, your pharmaceutical, your material science? And it's homage to thinking about it in that way, and realizing that these are tough problems. They're tough problems to think about, tough to get your head around, and so
Right.
provide tools that simplify it a little bit, even for these brilliant people, that comes with a lot of value.
Yeah, and one of the special things I think too is this is such a vertical application. Meaning, listen, I love horizontal, but I love vertical because it's just so much more applicable, and you're looking for less of who's going to use this. You're very centered on this. I mean, listen, not that your new NLP and AI stuff isn't sexy, but this has a use now for a very specific use case. And I think right now, at the state of quantum computing and the way that people look at it, I think these are the most important types of applications you can get out there to reinforce that this is real.
Yeah, get the right tools in the hands of brilliant people and let them tell you what they can do with the tools.
I love that. I love that. Imagine that, using an ecosystem and developers and customers to map out their future. I love it. Tony, always enjoy my time. I really appreciate you coming on here for the 6.5 Summit. Can't wait. Paul and I can't wait to get out there to see you again. I think the first visit was maybe before COVID hit, and I think we're going to have to meet up again in Colorado or wherever home is these days.
No, Pat, thanks so much for having me. Always
appreciate it. Thanks.